lecture 17. So we'll do the power series. We have already done what is a power series, and then we take the power series to the next level, Taylor's theorem and Maclaurin's theorem. Now we're gonna answer a few questions on this, right? So there are two major questions basically which we're gonna answer, and these are what? So very first point is when does a Taylor series converge to its generating function, right? So can you explain this question? What is this problem? Can you explain something regarding this? Any one of you?
So generating function means?
Yeah, I already explained, but let's say. So what is your generating function for a function for which we have written the Taylor series? So here the generating function is like log x. Okay. So for the function for which we have written the Taylor series, that is generating function, right?
Okay.
So what I'm saying is, so this is a basic question which we want to answer. That is, when does a Taylor series converge to its generating function? When does means what? Let's say we have, for an example, we have done this thing, right? Right? We know this.
Yes, sir.
Right? We have done it in terms of power series as well, in terms of Taylor series as well. So now this is what? Can you tell me this is what?
So it is the sum of an infinite GP.
No, you see, we need to change the vocab. That's it. We know that it's a sum of power series. So in this case, now we are dealing with
Generating function.
Yes. True. So we need to change our vocab a little bit. That's it. So it's a generating function, but these two are always equal.
No, sir. A condition is there. Mod X is less.
So basically, yes. So basically, we want to answer the question that when does really it happen that Taylor series equal to its generating function? Okay, so it may not happen every time. So basically, we're gonna answer this question when actually this happens. And secondly, what? So our second question is how accurately do a function's Taylor series, do a function's Taylor polynomial approximate the function on a given interval. So can you explain this question as well? So what does that really mean?
So what's the error between the two?
Exactly. See, what is the Taylor polynomials? We've done the Taylor polynomial. Kind of finite number of terms from the Taylor series, right? Roughly you can say this. Okay. So if you know that when your x is very small, you can actually approximate, let's say with finitely many terms, this much terms, right? But this equality will not hold. So we'll say what? This is approximately equal to this. Okay. So this is a kind of Taylor polynomial. Okay. P3x, right? Are you with me on this?
Yes, sir.
Yes, sir.
Yes,
So your f of x is approximately equal to P3x. Okay. So there has to be a difference between P3x and fx, right? So what kind of difference may arise when you are approximating Taylor polynomials with the you are approximating the function with the help of Taylor polynomials. Is it fine? So basically, we're gonna answer these two questions. When does a Taylor series converge to its generating function? First thing. And secondly, what? How accurately does it when you use the Taylor polynomial? So these two questions we're going to address in this particular exercise. Is it fine? Right? So
Yes, sir.
I'll write few theorems, but I'll not go to the proof of that. So basically we'll be focusing only these two things in this exercise. So that is RA. So for this, we need Taylor's theorem first. F and its n derivatives. N derivatives are, which are, of course, you know them, f dash, f double dash, and up to nth, are continuous on AB, and f nth, this function is on open interval AB. Then there exists a point C in AB such that this thing will happen. And what is that thing? F of B is equal to f of A plus f dash A B minus A plus f double dash A B minus A whole square upon 2 factorial plus f triple dash A B minus A whole cube upon 3 factorial plus so on. Then we'll have nth term f nth A upon n factorial into b minus a raised to power n plus f n plus 1 at c upon n plus 1 factorial into b minus a raised to power n plus 1. Are you getting this? Not really. Okay. So let me explain this thing. तो मैं ये कहना चाह रहा हूं यहाँ पे कि अगर हमने टेलर पॉलिनोमियल में n टर्म्स इंक्लूड करी, so these are n terms in the Taylor polynomial, right?
Yes, sir.
Now if you go for the Taylor series, तो होगा क्या कि infinite तक जाएगी, तो ये भी Taylor series है. तो basically मैं क्या कह रहा हूँ कि n के बाद की जो सारी terms हैं, that can be explained by this only term, and we'll have such C, ये यहाँ पे C है, so that कि अगर हम n term लेंगे तो बाद का ये जो term है, this will serve as remainder or error. Okay, and this can be done for every b, that means for every x. So basically we're gonna change that b into x and we'll write it as so change b to x, and we're gonna write it as f of x is equal to f of a plus f dash a into x minus a plus f double dash a 2 factorial x minus a whole square plus so on. Nth term derivative at a n factorial into x minus a raised to power n plus Rnx. And what is that Rnx? Which we have already explained. So Rnx is sorry, fn plus 1 at c upon n plus 1 factorial into x minus a n plus 1. Okay, so where c is what? C is some number between a and x. Okay, c is some number between a and x. And actually, what is your Rn? Rnx is what? This is a kind of remainder. Remainder after how many terms? After n plus 1 terms. Okay, after n plus 1 terms. Right? So you can see that we haven't explained the whole series. हमने infinite तक नहीं लिखा. So if you count these many terms, So these are what? N plus 1 terms. Okay. And rest infinitely many terms can be compensated by this Rnx, and the expression for Rnx is here. Right? Are you getting this? Bolo, samajh aa raha hai? So this is one expression which we're gonna use. Okay. Now, so basically, I'm reiterating the fact. Now, can you see this? Can you read in between the lines of these whole thing? I'm gonna write it in this way. Okay. So let me call this as star. So star can be rewritten as f of x is equal to pnx plus rnx. Can I write in this way? Are you with me on this?
Yes, sir.
Yes, sir.
कैसे बता दो जरा.
अगर टेलर पॉलिनोमियल करा था तो उस टाइम हमने उसको pnx की फॉर्म में डिफाइन करा था.
Yes, sir.
और कुछ नहीं है, ये सारा pnx ही है हमारा टेलर पॉलिनोमियल ये है ना. और ये है एरर वाला टर्म. तो ये fx जो है वो कैसे लिखा जा सकता है? pnx plus rnx, right? Okay, so now what I gonna say, so my next point would be, of course we can write it in this way, right? तो अब हम क्या कहेंगे, हम ये बोलेंगे कि rnx है रिमाइंडर ऑफ ऑर्डर n. इसको हमने बोल देना रिमाइंडर ऑफ ऑर्डर n, right? So that's how we label it. Okay, so rnx. Okay, so what are we gonna say कि कब होगा ऐसा? We say that now we say that Taylor series generated by f at x is equal to a converges to f. Converges to f. If, now this is important term and you're gonna get it. If rnx goes to 0 as n tends to infinity, right? You're getting my point? देखो मैं क्या कहना चाह रहा हूं, जैसे मैंने बिल्कुल पहले एग्जांपल ली. So what I'm trying to say is कि ये और ये दोनों बराबर होंगे, उस इंटरवल पे बराबर होंगे जहां पे अगर हमने एक हिस्सा पॉलिनोमियल का लिया है, दूसरा हमने लिया है रिमाइंडर का. So what we really want, we want that your rn should vanish when I take the infinitely many terms, right? So what I do say, so I'll pick n tends to infinity. So if n will tend to infinity, the terms in this polynomial, that means Taylor's polynomial, will keep on increasing, right? So eventually it will become what? A Taylor series, right? But in that case, your rnx must go to what? 0. तभी बनेगा ना ये. बात समझ में आ रही है? बोलो, ये चीज समझ में आ रही है? नहीं rn 0 होगा. देखो n इन्फिनिट को जाएगा. rn की टर्म, see rn is this expression, right? So don't take it as infinite. You will get more clarity about that when we do the questions. Okay, but अभी के लिए मैं क्या कह रहा हूं, जैसे जैसे देखो कोई अगर fx सीरीज के बराबर होगा तो कोई रिमाइंडर बचना ही नहीं चाहिए ना. We'll have no remainder if your fx is exactly expressed by the series. So when you take the infinitely many terms, that means you are not taking the polynomials. You are what taking? You're taking n tends to infinity. That means you're including every term of the series. So these two things must be equal only when your rnx will go to what? 0.
0.
You're getting my point?
Yes, sir.
Are you getting my point? Are you with me on this, everyone?
Yes.
Yes, sir.
Yes, sir.
You can understand, right? You can think of a picture, right? When you're this will no longer be a polynomial. This will become a series only when you take infinitely many terms, but along with the condition that your rnx must tend to what? 0. Okay.
0.
Right. So should I move further? So of course, in that case, this expression will become what? So this expression will become f of x summation k runs from 0 to infinity, okay, and fk at a upon k factorial x minus a raised to power k. Okay, are you getting this stuff, right? So let's do one question on this, and then we'll come to know that how the things are actually working. Okay, so let's say do this. Now see this. So what I'm trying to prove, always, just focus on this. So this is just an example. I'm not taking.
Can you please switch to the previous page?
Yes, please.
Yes, sir. Thank
Is it fine?
Yes, sir.
Okay, so let's do the question. So this is an important thing to note. Show that the Taylor series generated by f of x is equal to ex at x is equal to 0 converges to f of x for all real values of x, right? So let's see how it works. So we know that we have already done the Taylor series for that. We have already done in the previous lecture, right? So ex, the series of ex we already know, 1 upon x upon 1 factorial x square upon 2 factorial, sorry. And we'll keep on doing like this. So we have xn upon n factorial plus some remainder rnx, right? That's true. Is it fine?
Yes, sir.
Yes, sir.
Because we since we have done that part, that your ex function will look like pnx plus rnx,
RNX.
right? We have done this part. Okay, so now what is your rnx? Your rnx was fn plus 1 at some point c upon n plus 1 factorial into x minus a raised to power n plus 1, right? So that was the thing. But if you compare it with the function, your function is exponential. So no matter how many derivatives you take, it will still remain an exponential function. Okay, so your rnx plus 1, your rnx will become what? E raised to power c. Why? Because n plus 1 derivative of ex is ex. So you are now taking the derivative at c. That's why it becomes e raised to power c upon n plus 1 factorial into, now you have x minus a, and in this case your a is 0. Why? Because you are taking the series generated at x is equal to 0. So the center of the power series is 0. So that's why you take it as x raised to power n plus 1. Is it fine?
Yes, sir.
And for some c belongs to a and b, and a is what? Again 0, and b is variable, say x. Right? Can I do this?
Yes, sir.
Tell me, can I do this? Right?
Yes, sir.
Okay. Now see this. Now see this. This is an important explanation. So since ex is an increasing function, is it an increasing function?
Yes, sir.
Right? Increasing function. Therefore, EC, see, your C lies between what? Your C lies between 0 and x. Okay?
Yes, sir.
Right? So your EC will lie between what? E0, EC, and EX. So 1 and EX. Right?
Yes, sir.
Right? So what happens? If your C is negative, you know that. If your C is negative, your EC will be less than 1.
Yes, sir.
When your x is negative, sorry. If your x is negative, then it will happen. Okay. So let's say when your x is negative, I would say that then your x is negative. Because c will be something between negative and 0. So that's why your EC would be less than 1. Right? Okay. And if your x is 0, then it will be 0 over here. Okay. So then your Rnx will be 0. If your x is 0. Are you with me on this?
Yes, sir.
Yes, sir.
Right. So, and if your x is positive, even if your x is positive, if x is positive, even then your EC is less than your EX. So now overall, what I want to say is, if I take the modulus of this expression, this whole expression, what will happen? Say, so your Rnx ka mod is less than equal to what? Mod xn plus 1 upon n plus 1 factorial when your x is less than equal to 0. Is it fine? Bolo. Is it fine or not? हाँ भाई बताओ जरा. Is it okay?
सर नहीं आया.
देखो सीधी बात समझो कि अगर x नेगेटिव हुआ तो e रेज टू पावर c जो होगा वो क्या होगा? एक नंबर होगा जो कम हो जाएगा. ठीक है?
हाँ सर.
e रेज टू पावर समथिंग नेगेटिव करेंगे तो रेसिप्रोकल आ जाएगा ना.
Yes, sir.
Right? So reciprocal will reduce the number or increase the number. What do you say?
Reduce.
Reduce.
So if you remove that part EC, then your number will become bigger or smaller.
Bigger.
Bigger.
So that's why your number is bigger. See, it is bigger. This term is bigger than your Rnx. Why? Because you have removed this part. Okay. Are you with me? Tell me.
Yes, sir.
Yes, sir.
Sir.
Now you getting it?
Yes, sir.
Yes, sir.
You're getting it, right? Now, next part is if your x is positive. So when your x is positive, just an exercise, a small exercise, then it would be less than ex xn plus 1 upon n plus 1 factorial. Why is it so? Can anybody tell me? देखो ये ऐसे हुआ. ठीक है. c 1 से x के बीच में ही है ना. 0 से x के बीच में मान लो. 0 से x के बीच में है.
Yes, sir.
Yes, sir.
Yes, sir.
तो तुम्हारा EC जो है वो EX से छोटा हो जाएगा.
Yes.
Yes, sir.
Yes, sir.
What I've done, actually I've smartly replaced that EC by that EX. Why? Because your exponential is increasing function. So of course your EC will be always less than EX.
Yes, sir.
Yes, sir.
Right? Are you getting this?
Yes, sir.
Yes, sir.
So now you have these two cases. Right? So in these two cases, what will happen? Now see what will happen if you take limit n tends to infinity in both the cases. Let's say you take this case, mod xn plus 1 upon n plus 1. So what about this case? ये किसके बराबर आता है? Tell me. Okay, let me remind you. Limit n tends to infinity xn upon n factorial किसके बराबर आता है?
0.
0.
किसके लिए? किसके लिए? For all x. ये हमने किया था ना रिजल्ट.
Yes, sir.
सीक्वेंस में किया था. मैंने इसका प्रूफ नहीं करवाया हुआ, लेकिन मैंने जस्ट इसको रिजल्ट को करवाया था. याद है जिसमें हमने बोले थे there are two top 5 or 6 results which we gonna use it.
Yes.
Okay.
Yes.
So that was the part of the in sequence and series. That's what we have done. So now this whole thing, see, it doesn't matter whether it is n plus 1 or n here, because eventually you are taking n tends to infinity, right? Are you getting this?
Yes,
sir.
sir.
Yes,
So this will
sir.
become what?
0.
0. So
0.
no matter, even in this case, this will also become 0. Why? Because we'll take limit n tends to infinity. X has no rule to do, right? So EX will be outside and this whole thing will also become what? 0. So in both the cases, when you take limit n tends to infinity Rnx mode, then it will become what? it has to be what? 0 for all x. And as we have done the theorem, whenever your Rnx tend to 0, that means your series will converge to its generating function. Okay, so in this case, therefore, series will always converge to its generating function, right? Are you with me? Tell me. सही बात
Yes,
है?
sir.
Yes,
ठीक है?
sir.
और ये हमें पता भी है. We already know that this is true for every x, right? Okay. This is true for every x, right? Was it fine?
Yes, sir.
Yes, sir.
ये सारा समझ में आया? Anything you want to ask, you may ask. Anything you want to ask?
No, sir.
Okay. So let's the remainder estimation theorem. And what is that remainder estimation theorem? Let me explain this. If there are positive coefficients, positive constants, numbers m and r, two numbers are there. ठीक है? कैसे? Such that your fn plus 1 at x is always less than equal to mrn plus 1. Okay, for and something, let me call it as, let me change the notation because we have already x, so let me call it as t. For all t belongs to a to x. Okay, so a to x, then Rnx of in Taylor's theorem, जो पिछला हमने अभी किया है ना, we have already done the Taylor theorem. So in that Taylor theorem, Rnx can be expressed as how Rnx is less than or equal to mRn plus 1 x minus a n plus 1 upon n plus 1 factorial. Right? It's pretty much easy actually to prove it. See, हमारे पिछले वाले में Rnx कैसा था? कैसा था Rnx? Can you tell me? Fn plus 1 at क्या? C n plus 1 factorial x minus a raised to power n. Right? So now you see that these two terms are same. This, and this. These all are same, right? Okay. Of course, I should take it as Rnx. And if I take the mod of that, then these two terms would be same. I take the mod of that, right? So the things which I've highlighted, they are same, right? So only difference is between this and this. But this is what we have given to us. Okay, so we have given that your fn plus t, this is there, right? This is given to us, right? So we're gonna use this thing. Your fn plus 1 t is always less than equal to your mrn plus 1. So we have replaced this fn plus c by mrn plus 1. And this is of course less than equal to this. That's why here you have equality and here you have inequality. Is it fine? Can we do this?
Yes, sir.
Yes, sir.
इसमें तो कोई लोचा ही नहीं है ना, आराम से ही हो जाए, है ना? So it's pretty much easy. Okay, so see how we're gonna use it. Again, it's very easy. You can think of this. So I'll do last question on this particular theorem. Okay, so ये जो हमने अब ये फॉर्म लिखी है ना, that how to use this in question. That's what I'm saying. So show that example. Show that the Maclaurin series for sin x converges to 2 sin x for all x. See, that's what we want to prove. जब भी हमसे क्वेश्चन में ये पूछा जाएगा, whenever somebody asks us that what is if it is converging for all x, that means we need to prove that, basically we need to prove that limit n tends to infinity Rmx has to be 0.
0.
Okay. Right? Are you getting this? So क्वेश्चन में अगर ये पार्ट है,
Yes, sir.
तो उसका मतलब बस यही है कि you need to prove that this thing will happen. Okay? Our f of x is sin x, f dash x is cos x, right? F double dash x minus sin x, f triple dash x minus cos x, fourth derivative sin x, and so on, right? That's what we do. Okay, and f of 0 is 0, f dash at 0 1, f double dash at 0 is 0, f triple dash at 0 is -1, and f, again the fourth derivative at 0 is 0. So you know that if you take even derivatives and you pick it and you calculate at 0, it will become 0, right? Because at even derivatives you always get the sin x back. So when you take the value at 0, of course you will get 0. But if you are taking the odd derivatives, you are getting cos x, right? So in odd derivatives, you are actually getting the -1 raised to power k into cos x. So of course, if you take at 0, so this will become -1 raised to power k. Are you with me on this? This is something which we have already done.
Yes, sir.
Yes, sir.
Yes, sir.
Series में already कर रखा. Okay, so now we have n is equal to 2k plus 1. Okay, so now see this. Now we want to write it as Tnx plus Rnx. Am I right? ऐसा ही होता है?
Yes, sir.
So here you need to take Rn as here you need to take n as 2k plus 1, right? So that's why you can always write it as sin x is equal to x minus x cube by 3 factorial plus x5 by 5 factorial minus and so on. चलते चलते लास्ट में हमारी टर्म -1 raised to power k x raised to power 2k plus 1 2k plus 1 factorial in plus r 2k plus 1 x. So why I'm taking n to be 2k plus 1? Can anybody tell me? Can anybody tell me?
Sir, because we have to consider only odd terms.
No, it's not like that. See, in EX it was pretty much easy, right? If you talk about x square, that means you talk about x square. You talk about x cube, you talk about x cube. So you already know that the numbering is pretty much easy here. तो यहाँ पे अगर 2 है तो ये तीसरी टर्म है ना? यहाँ 3 है तो ये कितनी टर्म है? फोर्थ टर्म है. But it is not true for the case of sin x. Why? Because some of the terms got vanished. तो यहाँ अगर x क्यूब है तो ये चौथी टर्म तो नहीं है ना? ये कौन सी टर्म है? दूसरी टर्म है, राइट? क्यों?
Yes, sir.
क्योंकि बीच में कुछ टर्म वैनिश हो गई. So if we are reaching at 5, that doesn't mean that we have included 6 terms. Actually, this is a third term, right? So just because some of the terms got killed, we need to consider more number of terms in order to reach at 3 terms. Okay, so that's why if we want to reach at n terms, we need to consider 2k plus 1 terms. Why? Because even terms will get vanished. Okay.
Yes, sir.
And that's why. And secondly, this is your R2k plus 1. That is what? Rnx. That means remainder after Pnx. So that's why we call it as R2k plus 1. Fine? Fine?
Yes, sir.
Yes, sir.
Now see this. Now your Rnx actually written as what? Fn plus 1 c upon n plus 1 factorial into x minus a raised to power n plus 1. Okay?
Yes, sir.
So in place of n, we will take what? 2k plus
2 + 1.
Yes. So this becomes your f2k plus 1. Okay. So let me take the mod on both sides. So which is less than 2k plus 1, 1 upon 2k plus 1 plus 1. That means 2k plus 2. And a is 0 because we are taking the Maclaurin series, and x raised to power 2k plus 2. Fine? Fair enough? Right? Are you with me?
Yes, sir.
Yes, sir.
फर्क क्या पड़ा? मैंने यहां पे 1 लगाया. वो 1 क्यों लगाया मैंने? 1 क्यों लगाया?
क्योंकि सर मैक्सिमम 1 वैल्यू हो सकती है.
साइन आता, कॉस आता, मैक्सिमम 1 नहीं आना था, राइट? सो इफ यू कंपेयर इट विद योर रिमाइंडर एस्टिमेशन फॉर्म हियर, एंड इफ यू कंपेयर m and r, actually your m is 1 and your r is 1. Okay, so here your m is 1 and r is 1. I'll take more example on this. Anyways, so we'll come back to this. So anyways, your r2k plus 2x is nothing but is less than equal to mod x raised to power 2k plus 2 and 2k plus 2 factorial.
0 हो जाएगा ये.
Of course. So now you take limit n tends to infinity. That means you take 2k plus 1 tends to infinity. That means you take k tends to infinity. So if you take limit k tends to infinity.
Sir,
Yes.
अब पे R2k plus 2 की जगह R2k plus 1 नहीं आना?
Yes. Sorry. It was 2k plus 1. Yeah. Thanks for the correction. Okay. Right? Fair enough? So again, by the same argument which we have used over here, ये इसमें भी यही यूज किया था ना, ये वाला, कि ये लिमिट क्या होती है? 0. Right? So we'll use the same argument over here. So this will also what? 0.
Yes, sir.
So that means, and this is true for what? Every value of x. Right? For all x. So therefore, series of sin x converges to sin x for all x. Let's say if I take fx to be 2 sin 3x, then actually your m is 2 and your r is 3. Right? Why? Because if you considering this fn plus 1 होगा क्या? fn plus x लोगे तो क्या होगा? ये दो तो कांस्टेंट ही है ना, जितने मर्जी डेरिवेटिव ले लो. और साइन के अगर n plus 1 डेरिवेटिव लोगे तो 3 को कितनी बार बाहर आना पड़ेगा? n plus 1 बार.
Yes,
है ना?
Yes.
और
Yes,
साइन
sir.
कोस कुछ भी हो, उसकी वैल्यू तो फाइनली लेस देन इक्वल टू क्या बन जानी है? 1.
1.
So that's why here you have m, here you have r, and that's why you write it as mrn plus 1. ठीक है? अब हमने कौन सा केस किया? We have done fx is equal to sin x. So if you think of here, m is what? 1.
1.
Even your r is what?
1.
1.
So that impact was not visible over there as such, है ना? तो वहां वो दिखा नहीं उतना अच्छे से. Okay, but if we do a slightly changed problem, something like this, then of course we'll have different values of m and r. Okay.
Yes, sir.